Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Real Analysis that has appeared in the CSIR National Eligibility Test held on December 15, 2019. This question is related to the concepts of a monotone function. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. The question ID is 187-980-1804. And this question is suitable for all these examinations. Right. The given question is, let f be a function from the unit closed interval to the set of real numbers given to be a monotonic function with f of 1 by 4 multiplied by f of 3 by 4 is a negative. Suppose the supremum of the set consisting of x belongs to the unit closed interval such that f of x is negative is equal to alpha. Which of the following statements are correct? We are given four options. Option 1, f of alpha is a negative, and if f is increasing, then f of alpha is less than or equal to 0. Option 3, if f is continuous and 1 by 4 less than alpha less than 3 by 4, then f of alpha is equal to 0. Option 4, if f is decreasing, then f of alpha is a negative. Right. So the question is basically the properties of monotonic functions, and in particular in some situation in the option 3, it is about continuous functions. Right. So without saying that you need to apply the properties of monotonic functions and continuous functions. Right. Let's now discuss the solution of the problem in detail. We are given a monotonic function f from the closed unit interval to the set of real numbers satisfying f of 1 by 4 multiplied by f of 3 by 4 is a negative. Mind you, you are not given the continuity for the function f in this question. So unless it is mentioned f is continuous in some of the options, don't use the properties of continuous functions. That's the caution that I am giving to you. It may be noted that the continuity of f is not given. Right. Now let it is given A is equal to the set consisting of x belongs to the unit closed interval wherein f of x is negative. Let that be A, and it is given supremum of A is equal to alpha. It is given this one. We have named for this set A. Right. Right. Now let us call on option 4. If f is decreasing, then f of alpha is a negative. If it is true, we prove. If it is not proved, then we look for a counter example. I think we can try to give a proof. We have f is decreasing. It's a decreasing function. So, and it is given f of 1 by 4 into f of 3 by 4 is a negative and f is decreasing. These two things you put together will give you f of 1 by 4 is positive and f of 3 by 4 is negative because it is decreasing and the product is negative. Agreed. Now, f of 3 by 4 is negative, means 3 by 4 belongs to the set A, right? And 3 by 4 is less than or equal to alpha. Why? Because the supremum of A is alpha and 3 by 4, supremum of A is alpha, 3 by 4 belongs to A. Therefore, 3 by 4 must be less than or equal to the supremum of A, that is less than or equal to alpha. Agreed. Now use the decreasing nature. It is decreasing. 3 by 4 is less than or equal to alpha because it is decreasing. F of 3 by 4 greater than or equal to alpha because f is decreasing. And reverse this. This will imply f of alpha less than or equal to f of 3 by 4. But f of 3 by 4 is negative. So which is less than 0. This implies f of alpha is negative. So thus we have proved the result. That is given in 4. Thus option 4 is true. Agreed? So here in this we have used the properties of decreasing function. That's all. Now we take the option 3. If f is continuous and 1 by 4 less than alpha less than 3 by 4, then f of alpha is equal to 0. Right. Now given f is continuous and you are given 1 by 4 less than alpha less than 3 by 4. Therefore, f is continuous in 1 by 4 to 3 by 4. And you are given f of 1 by 4 into f of 3 by 4 is negative and f is continuous in the interval 1 by 4 to 3 by 4. So use the intermediate value theorem IVT. Then there exists a point beta belongs to the open interval 1 by 4 to 3 by 4 such that f of beta is equal to 0. There exists a point. I'm not sure how many points. That exists definitely a point. Beta belongs to this, f of beta is equal to 0. Now, what we have to prove? Alpha lies between 1 by 4 and 3 by 4. We have to prove f of alpha is equal to 0. But we got f of beta is equal to 0 where beta belongs to 1 by 4 to 3 by 4. Is beta same as alpha? We do not know. Case 1. What can be f? F can be monotonically increasing, f can be monotonically decreasing because it is given to be a monotonic. So case 1, let f be monotonically increasing function. When it is a monotonically increasing function, f of 1 by 4 multiplied by f of 3 by 4 is negative, means monotonically increasing, and this product is less than 0 means f of 1 by 4 is negative and f of 3 by 4 is positive. That means it will increase. Agreed. So therefore A, what is that A given to be? Set of all x belongs to the closed unit interval, f of x is negative. Now f of 3 by 4, f of 1 by 4 is negative. F of beta is 0. Beta is in between 1 by 4 and 3 by 4. So, where is this function f of x is negative? In this interval, 1 by 4 to beta, in this. Now, what is alpha? Supremum of A. What is supremum of the open interval 1 by 4 to beta? It is beta. So thus alpha is equal to beta. We have already seen f of beta is equal to 0. Therefore f of alpha is also equal to 0. So thus we got the result. Then f of alpha is equal to 0. But this is the first case what we have considered. F is monotonically increasing. Then this is true. So, case 2. Let f be monotonically decreasing function. When f is a monotonically decreasing function, f of 1 by 4 multiplied by f of 3 by 4 is negative, will tell us f of 1 by 4 is positive and f of 3 by 4 is negative. Agreed. You have to use the product of these two is negative. You have to use the property of decreasing function. So, now consider we have, therefore A is the set of all x belongs to 0 to 1. Fx is negative. F of beta is 0. F of 3 by 4 is negative. It is a decreasing function. Beta to 3 by 4, it will be negative. Beta to 3 by 4, it is negative. Therefore, A will be the open interval beta to 3 by 4. Agreed. Now, alpha is supremum of A. That will be, supremum of A is 3 by 4. Alpha is 3 by 4. It's a contradiction. Why? Alpha is given to be less than 3 by 4. 1 by 4 less than alpha less than 3 by 4. So, alpha is given to be 3 by 4. Now, we got alpha is equal to 3 by 4. It's a contradiction to the fact alpha less than 3 by 4. Therefore, this case that f is monotonically a decreasing function does not arise. So, we have only one case. In that, we have already proved f of alpha is equal to 0. Thus, f of alpha is equal to 0. Thus, we have proved option 3. Therefore, option 3 is true. So far, option 4 and option 3 are true. Let's move on to option 2. If f is increasing, you see, here what we are talking monotonically increasing, not strict increasing or whatever it is, just increasing, monotonic increasing, then f of alpha less than or equal to 0. Is it true? That's the question. Right. There are examples, where this may not be possible. So let us consider this example. Let f of x is equal to minus 1 when x belongs to the semi-closed interval, that is 0 to 1 by 2, closed at 0 and open at 1 by 2. And it is equal to 1 when x belongs to the closed interval 1 by 2 to 1. And note down that there is a jump at 1 by 2, So it's monotonic. And we are not assuming anything. But this is the example what we are considering. So, it's a monotonically increasing function from negative values to positive values it goes. So, monotonically an increasing function. But what is f of 1 by 4? It is minus 1. F of 3 by 4, it is plus 1. And the product is minus 1. So, the given property is also satisfied. Agreed. It's a monotonic function from the unit closed interval to R. So, the hypothesis is okay. Now, A is equal to the set of all x belongs to the unit closed interval where fx is negative. Where is fx is negative? In the first interval. That is the semi-closed interval 0 to 1 by 2. And what is the alpha? Is the supremum of A. What is the supremum of A? It is 1 by 2. So, now f of alpha will be equal to f of 1 by 2 because alpha is 1 by 2. F of 1 by 2 value is coming as 1 from here, 1. But 1 is greater than 0. But in your option, it is given f of alpha less than or equal to 0. But we got f of alpha is strictly greater than 0. Therefore, option 2 is not true. Move to the last option. Option 1. F of alpha is negative. The same example, the above example will work here. In that f of alpha is greater than 0. But what is wanted is this one. What is f? On f, no condition is there in option 1. It's a monotonic only. Why not we take f is a monotonically increasing function and take the same example. So consider the above function because on f, what type of monotonic function, whether it is increasing or decreasing, is not given. Therefore, we have taken increasing. Therefore, in the above example, we have seen f of alpha is 1, which is strictly greater than 0. But our option is strictly less than 0. Therefore, option 1 is not true. So, summarizing all the 4 options, option 3 and option 4 are true. Option 1 and option 2 are not true. Therefore, the answer to this question is options 3 and 4. That is the detailed discussion of the solution of this problem. And I've been telling you that, whenever you look at a problem, what are the concepts that are involved in the problem, and what results have been used. In this, the properties of monotone functions are used, and the properties of continuous functions are used, and you use your intelligence and combine them. With these few words, I say, I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Right. We are sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.